So we have a rod and a cable that supports a 500 pound. So this one is 500-pound ball. Okay. And the question is, what are the force into the cable and into A? So at A, we have a AX and a AY. Oops, did I make it opposite? AX and AY. And at C, because it's a cable, we have a force in the same direction. Okay. And the cable can only pull. Okay. So that's T. I can write T there. I can write T there. That's the exact same thing. Okay. We can always slide a force along its line of action. But I think, yeah, both of them will work. Okay. So which equation can we use to find T first? What looks the most logical is to do the moment about A. So sum of the moment, and I click, sum of the moment about A equals 0, right? So what do we have if we do the moment about A? We have this distance that is 8 cosine 35. So, and this 500 is going in the negative directions. So minus 500 times 8 cosine 45. Okay. And for T, okay, we don't know the distance between those 2 points. Okay, so that would be easier to use T there because we have this 8 and cosine and 35 degrees. So we have two complements of T. Okay, let me write the T there and try to have enough space. We have a T that I would call Tx, and we have a Ty, right? And we have the 22 degrees that is the same than this one, the internal angles. So we have, for the moment about A for T, for Ty tends to rotate in negative direction. So we have minus Ty times the same 8 cosine 30, cosine 35. Okay. And for the horizontal one, let's make it in purple. That's the distance that we want, is the vertical distance, so that's 8 sine 30. And Tx tends to rotate in the positive direction about A. So plus Tx times 8 sine 35. Okay? And everything is equal to 0, the total of everything. So let me write my equation on the bottom. We have minus 500 times 8 cosine 35 minus Ty. It's T, that's the same, and this one, sine 22 times 8 cosine 35. So I'm there in my equations, plus Tx, and Tx it's T cosine 22 times, this time 8 sine 35 equals 0. Okay, so this one, let's simplify a little bit. 500 times 8 cosine 35, that's minus 3 to 76.6. And there we can group T, so plus T, and we have minus sine 22, 8 cosine 35, and plus cosine 22 times 8 sine 35. And instead of equal to 0, let's put this equal, and I inverse the sign. So we have T, it is equal to this divided by all this term. So don't make mistake for your parentheses. So minus sine 22 times 8 times cosine 35 and plus cosine 22 times 8 and times sine 35. That's 1, 8, to 1, and that will be pounds. So that's the force T. Oops, in the cable. If you want to find, if you want to find a ax, we do sum of the forces on ax equals 0, and what we have is we have ax that we don't know minus t, the complement on ax, cosine 22. That's equal to 0, so we have ax that is equal to 8, 1/8 to 1 cosine 22. Oops. This one cosine 22. That's 1688 pounds. And for the y, we can do sum of the forces on y. It's equal to 0. So on y, we have a y plus minus t sine 22. And don't forget the minus 500 equals 0. So we have a y that is equal to t 1821 sine 22 plus 500. Oops, let me come back on this data. Oops, sine 22 and plus the 500. That's 1, 1, 8, 2 pounds. And if the final question is, oh, I will check my answers, is to find the force in the pin A, that the square roots of ax square plus ay square. So that will give us, oops, the square roots of this one square plus this one square. That's 2060 pounds. So 2.06 kilopounds. And I think that's it. We found T, and we found the force A in the pin and the force T in the cable that are the same than this one and this one. Remember, we can slide our forces. That's it. Bye-bye.